Hey y'all, my name is Tally Barnhill and welcome to my microbiology podcast. I'm actually coming to you live from my music room. So this is definitely a new experience for me. So the topic of our podcast today is going to be floor fungi fracture phthalates. What a mouthful. I think I got tongue twisted 1,000 times before doing this video. Anyway, but before we get into our topic, we're going to do a little something called a microbe of the episode. So our microbe of the episode is actually going to be the Rosa rugosa leaf distortion virus. Another mouthful. Anyway, but this microbe is actually a species of rose from Asia. And it grows on one of my most favorite places ever, which are beaches and sandy areas, which I guess is a bad thing in a way. It also has rugose leaves, which are ruffled. They kind of look like ruffled potato chips. A favorite snack of mine, which the more I'm thinking about it, I'm relating this virus to all the things that I like, and I'm kind of regretting that now. Anyway, but this virus was discovered in 2013. And fun fact about this kind of type of virus is that roses are very hard to keep healthy because they get infected with so many things, bacteria, other viruses. I mean, you name it, you can't keep it alive pretty much. So that's why when you see a rose bush that is super, super healthy, it's kind of like finding a diamond in the rough, which is not common. Anyway, but now on to our story, talking about phthalates and indoor and outdoor environments and the difference kind of between the two. So, moving on to the story. The diversity of an indoor environment is actually way more controlled and less diverse than what's on the outside. One of the reasons is because on the inside, we're more clean. We're conscious about making sure things are cleaned up, or using specific chemicals in labs to make sure everything's sanitary. But then again, we still don't have that same atmosphere environment from the outside to give us the all the diversity that the outside has. We don't have grass and plants and all that stuff growing normally. Anyway, so like I said, the indoor environment is way more clean than outside and has many chemicals that actually come off man-made materials and substances like furniture, building materials, pretty much so anything that can leak chemicals is going to come off of it. So an example of this would be phthalates esters, which are a kind of plaster. So just a little bit of background of these chemicals is that the phthalates are used for many different things actually, but most commonly used in building materials. So these building materials consist of PVC pipe, adhesives, vinyl flooring, anything of those natures. I think of it as a way to either connect stuff or stick stuff. Anyway, so the chemicals actually leak from those materials and migrate into the environment. So hold up, let's think about this. Chemicals are actually leaving those materials to build buildings, per se, seeping from those materials and leaving their marks kind of everywhere, migrating into, it could be chairs, it could be flooring, it could be dirt outside, it could be anything, you name it. And so therefore you can actually ingest or inhale them. They can actually seep into your skin. I mean, I think about moisturizers or cleansers or stuff like that, and how even sunscreen, it seeps into your skin. It's supposed to protect you, it's supposed to help you, it's supposed to be healthy for you. And these chemicals do the same thing, and it's not healthy. And it can be very harmful, because once the chemical actually enters the body, it mimics the hormone estrogen and can cause hormone disruption if the levels are high enough. So researchers have actually proven that microbes and household dust can in fact break down some of those chemicals. After testing some samples of dust from a vacuum cleaner, a carpet, even a broom, it was found that the indoor environments were actually above 80% humidity, which aren't considered uncommon in homes, but from previous work, from previous research, and in the other podcast, or the original podcast, excuse me, it actually said that the microbial activity and dust is higher at these conditions. So the microbial degradation of phthalates has also been observed in like environments such as soils or surface waters. But we aren't quite sure, if it was happening in houses until now. And we're able to actually provide evidence and actually physically see the evidence of how to degrade these phthalates. So in the first experiment, there was a decrease in some of the phthalates, but we weren't clear if, researchers weren't clear if the breakdown came from microbes or other processes. So, to prove their point, they added another phthalate to kill the dust. So what they did was they took half of the dust particles, phthalates, all that good stuff, and then they sterilized it with a particular microbe. And then the other half, they kind of just let it do its thing. So this way, it was possible to actually observe the degradation pattern with and without the process of the microbes. Well, of course, they found out what was the deal. And so the experiment actually showed that the phthalates degraded on its own without the microbes. But in the presence of the microbes, it actually degraded a lot faster, a significant number, over the course of a week. So, with that said, this actually proved that the microbes do in fact contribute to the degradation of harmful chemicals in household dust. Just as long as those chemicals that we're using to degrade the chemicals and all that harmful crap, pretty much, just as long as it's those chemicals themselves aren't as harmful as the original chemical. Because when you start getting into all that, it's like, which is the better option, the one you got or the one that you're trying to kill the one you got? And it's a lot harmful. I mean, they're harmful both ways, but pick your poison, in other words. So they were asked on the original podcast for future work, and they decided that some future work for this topic would be to actually observe the microbial functioning at lower humidity conditions, for longer periods of time, which is typically more common in most homes. So like that 80% that they found out that the humidity was pretty high. Because the EPA actually suggests that in our homes, the relative humidity should be between 30% and 50%, and definitely below 60% of that relative humidity. So the conditions in this study were not really recommended for any home. It was more in a controlled environment, and just for the sake of this study, pretty much. So, after, going through the original podcast and gathering information on my own to help film this video, I've pretty much discovered that phthalates and all these other chemicals that seep into the ground or seeps or, all this stuff that we're around all day, it really makes you almost want to go like wash your body or wash your hands like every 30 minutes, or at least it does me. Because I think about if these phthalates seep from building materials and PVC pipes and that adhesive and the vinyl flooring, and we're kind of like around this all day, and it can get on furniture, it can get on anything literally, and then we're sitting on this stuff, and then we're bringing it home to most of the time go jump on our bed. Then that's transfer of more chemicals that we don't intend to, but we just don't think about it. And definitely this original podcast and then going through and researching all this has made me very aware that the world can kind of be deadly. And I don't mean deadly as like, oh my gosh, everything we touch is we're going to die. But it just makes you aware of that there are definitely things out there that can harm you. But, you know, thankfully, we just keep on moving. So, I hope y'all enjoyed this topic. Definitely a lot of words that had me tongue-tied. I'm still tongue-tied. But I hope y'all enjoyed it. I hope y'all learned a little something. I hope y'all, maybe this will help you in your microbiology class or on a test or a quiz or whatever. So hopefully I was here to help y'all. Hope y'all have a good day, and yep, that's about it. Thanks.